Right, I think that that's the end of the messy bit for a while. So just cleaned up, had my cup of tea, and the parts that we're going to need for this next little bit: the transmitter, receiver, charged battery, and the speed controller. Not forgetting the little bag of servo horns and screws for this servo, and something which I've learned through bitter experience is it's worth having a little place to keep them, especially that screw for the servo horn, because that may not be a common size. It's probably M2, but it might not be. Okay, so batteries are in the transmitter. I'll just turn that on. Now this one is mode 2, so the steering channel is going to be over here, and that's actually going to be channel 1. The reason why I've put stuff on the front of the transmitter really is because I've got a number of these, and it's really frustrating when I get confused between which model and which transmitter I'm using. I think that I'll actually put some of these up on Thingiverse so that people can alter them or print off their own ones as well. So taking the lead for the steering servo, I'm going to put it into channel 1, which is down the bottom here. With these receivers, the white or orange wire, the signal wire, is always at the top. I think that the throttle is channel 3. Really for this it doesn't matter, but I'll put it in the right place anyway. So that's going to go there, on the speed controller. Plug in the battery. You always have to make sure that first of all you're putting the battery into the right lead with this, and in particular that you've got the right polarity. Check to make sure that red is going to red, because if you want to fry one of these speed controllers and get smoke, put it around the wrong way and it will destroy itself almost instantaneously. So just put that in there. So we're going to need to bind the transmitter, and the bind socket is actually right at the very top, so I'll just put that in there. Turn it back on, blinking light. On the transmitter, and hopefully you can see this. Go into the main menu, scroll it down, RX bind, push that, and we've got solid lights here, which means that we're done. And if we go back to the main menu, you can actually see that it's reading the receiver battery value and the transmitter as well. So that is good, and if I move the stick, we've actually got movement on the steering servo. Okay, so taking the arm, which looks like that, I know that I'm going to want the 4th hole up, and actually I'm going to want to reduce the overall height of this anyway to get it to fit in there. So I'll just count up the holes. 1, 2, 3, 4. So I'm going to want that hole. So at the 5th hole, I'm actually going to chop it across there and just round it off slightly. Then taking my Z bender, and it really doesn't matter which way round for this particular one, I'm just going to stick a bend in, like so, and there's probably much more material there than I actually want, so I'm going to trim that down. I'll just use a pair of pliers. We don't really want that end piece there being too long, so I'm just going to chop that down a bit there. Got to watch your eyes with that sort of thing, because you don't want a piece of metal flying that direction, which is why I was doing it across from me. And work it into the hole, like so. You can see that this is coming up at a bit of an angle. I'm going to have a quick look underneath, see what's going on, because I can't remember what I did with the other one. Okay, so it seems to be coming in a really unhelpful place, so let's just trim out some of this plastic. So there's a bit there, bit there. Get my pliers in there, give it a twist. I think that that should now be out of the way. If I now put that in, I think you would agree that that's a lot more useful. That isn't binding on anything when it's moving. So if we can get it to work like this, when the model's all put together, it should work even better. The next thing to do is to get everything central there. Take our servo arm, put it as straight up as possible, but actually fitting on the splines. So let's just try and do that. Make sure it goes on quite firmly. I'm actually going to screw it down as well. You have to be really careful with these when you do that because it's so easy to strip the gears. So you have to make sure that you're holding the arm at the same time. Because I want that really straight up, I'm actually going to centre it using the sub trim on the transmitter. So you just go into the menu, sub trim, this was channel 1, and then use the up and down arrows until it's vertical. I'm going to go up in 10s. That's okay. Tick, back, yes to store it. Okay, so you'll see that we've got a much more vertical servo arm there. That way we're going to get even steering in each direction or something close to that, I would hope. The next thing is we're going to need to Z-bend this rod so that it fits on there nicely. So I'm going to get the thing lined up centrally, take my Z-bender, and I can see where I want this piece here lined up to. Let's get it over the top. That looks about right. And I think that that's going to come roughly where I want it. Take that out. Chop it off. I'm going to try and hold both sides this time. What I'm going to do is I'm going to go through with my 1.5mm bit. Like so, and just make that hole a bit bigger. And then going from behind with my servo rod, like so. And you can see how it's resisting going into that hole. So what I need to do is I need to slightly bend this rod so that it will. So I'll just take that out for a moment. Probably about there. I'm going to put a bend in, test that. I think that that's going to be okay. I'm just going to put a tiny bit more in so that there's absolutely no strain whatsoever, just the tiniest bit. That's it. That's in there. I think that that is going to be absolutely fine. Put that in there. Undo the screw, again holding on to the servo horn. Pull that through. So. Do that. Okay, let's see if we've got steering. I would say that we have. And I think that we need to bear in mind that while it hasn't got the support from the top of the body, we're not going to get anything precise here in terms of setup, but we have something which seems to be working here. Doesn't seem to be going beyond the travel limits of the servo, and if it did you would start reducing that, but I think that that's probably something that you would want to do more towards the end of the build when you've got the whole thing together. The next thing to do is to think about motors. Okay, if you're using this particular battery, one of the slight issues is that it's intended for receivers, and as a receiver pack it actually has a 3-pin plug on the end of it, even though only 2 wires are going into it. So you're going to need to change that, and I'll just do this quickly. Now the plug you're actually going to want happens to be sitting on the speed controllers. So thing to do, chop the wires on the speed controller, and the way to know that you're chopping the right one is it is the smaller of the two. So let's just do that. Probably inch and a quarter, something like that. So chop that. Might as well just strip some wire off the end. You don't need a whole lot. I like to twist it. Right, so we have that, and then we just put the speed controller to one side for a moment, and then we have to think about chopping the wires on the battery. Now, the one thing that I would never do is chop both of these wires at the same time. First of all, whilst doing so, you would short out the battery, and actually you end up with 2 wires that, if they come into contact with each other, again you'll short the battery, which is not only likely to destroy the battery but could actually cause a fire. So you only ever chop one of these wires at a time. This isn't going to be needed, so it really doesn't matter how close you chop it, so I'm going to probably do it about there. And leaving the black wire still attached, I'm going to strip a bit off there. This is where it can be quite handy to have one of these things. So we'll just put that there. Heating the soldering iron up to about midpoint is probably going to be okay. So we'll just leave that heating. Not forgetting to wet the sponge, because it's good for wiping the end of the tip. Get the solder ready, and a little bit of 2mm heat shrink. That shrinks to about 1mm, so that's just right for what we need. Tin both wires. Tin the wire on the battery. That's a good joint. Get that over there. Shrink it. Do the other one just the same. And whatever you do, check and double check that you've got red to red, black to black. Now we can get into prepping the first speed controller, and we will be returning to this one when we put the second one in, but for the time being we'll just do this. These plugs I think are called mini Deans. I'll make sure that I'll put a link of some sort in, but if you want the model to be able to easily detach the bottom half from the top half, it makes sense to put these in. You don't have to do this, but if you try and separate the chassis from the body, you can't just unplug everything. You'll end up having to undo screws on a terminal block. So while I was building it, I actually found it easier to put this in place. The 2 prongs at the back get tinned, just makes it easier to stick the wires on. Then you take the 2 wires where we chopped it earlier. This doesn't actually matter which way around you do it. Tin those, more heat shrink, and then solder the wires on. Doing this first helps stopping you accidentally cutting some wrong wires later on. The next thing that we want to do is we want to get rid of the switch, because we actually want to be able to turn both speed controllers on and off at the same time using a single switch. And the other thing we want to do is we want to save some room inside the model where we're going to put the speed controller. So what we do is you take the wire with the switch on it, chop it probably inch and a quarter away from the speed controller, both wires, like so. Strip them, twist, tin them, heat shrink. So you don't want these wires so short that you can't get this over. Push that well out of the way because we don't want it melting while we're soldering. Bend the wires round so that they meet. A little bit of solder on the end there. Stick them together. Shrink it. So that's going to leave the speed controller in a permanently on position. And then while we've still got this wire handy, what we're going to do is we're actually going to put that in this circuit here so that we can have an on-off switch on the model. Chopping the red wire, inch or so in. So we have a fully prepped speed controller. We will at some point be coming back to this and actually putting the other speed controller in line around here on the wires so that it can share the common battery power, but we certainly don't need to do that yet. Taking some more silicone coated wire, and this again came from Component Shop, but it's slightly thicker than the other one, probably a couple of millimeters thick, probably about a quarter of an inch at each end. And then taking the second one of those little plugs, put that down a second, going to clamp that. I don't think it really matters which one goes in which, but just for the sake of neatness, if I just plug the other one in the other side, the red one on the top, so just do that, and the black one on the other side. Yet again, you guessed it, heat shrink. We're going to want to put one of these into each side of the terminal block. Okay, just before we get started on the motor, I wanted to tidy things up a little bit. I've stuck the speed controller onto the back of the chair using some double-sided foam tape. I've used some normal double-sided tape just to stick this piece down underneath there onto the servo so that it doesn't fall off when we're taking the top on and off. The speed controller plugs into the terminal block, like so. The receiver tucks away nicely underneath the seat. Plug in the speed controller into channel 3, just tuck away its wires, like that. As I said before, this is all very temporary, but it's actually easier to work on the model if you've got all of this stuff kind of tidy stashed away, and you're far less likely to accidentally cut something or damage it. And then I'm just posting the aerial wires down those holes there, just really somewhere to put everything while we're doing the testing. And when we have got the wheels on, I'll be using an elastic band to hold the battery down there, and that should keep everything out of the way. Right, time to do our first motor. So taking one of these 6 volt 100 RPM N20 gearbox motors, we're going to do the one at the front here first. And the thing to remember is that I found that if you look at the motor carefully, you'll see that there is a gear here near the back, and on the other side there isn't. This is the one which I found is best to have on the outside of the gearbox case. Now the motors click into these quite well, and they're not really intended to come out. Certainly when I made these with PLA, when the motor was in, the only way to get it out was to actually cut the plastic. I don't know if that's going to be the case with this, but I'm not taking any chances. So what we're going to do is we're going to solder some wires on before we actually put it inside the motor case. it's actually quite a good idea to hold the motor while you're soldering it. So remembering that this is the one which is going to be on the outside of that, I'm having that facing sort of upwards, and I'm just gently gripping it in the vise there. And then I'm going to take my red and my black 1mm silicone coated wire, and I'm going to chop off about 6 inches. I don't think we're going to need quite as much as that, but it's easier to chop it than add to it, so I'll just do those. If these do turn out to need to be longer, I no doubt will have put a comment on the video at this point. Now, you definitely don't want the soldering iron up too high for this. At the moment I've got it in about the vertical position, the little white line there. That's probably the most you want, but with time you'll get used to your own soldering iron, whatever it is. But with these very thin wires, you really do not want a massive soldering iron that heats up to a ridiculous temperature, because you actually risk melting the back of the motor casing here, and then you're going to have trouble with the motor bearings. These wires need to be stripped at each end. If you're very careful with the side cutters, you can probably do it. For the motor end, you don't need to strip very much at all. For the other end, probably a little bit longer. So I would say for the other end, maybe 8mm and perhaps 4mm for the motor end. I'll just do the black one as well. These wires need to be tinned, and because the wires are so tiny, it's actually easier to prop up the soldering iron somewhere and bring the wire to the soldering iron rather than the other way around. With these things, it's not about having the most expensive tools, but it's about having the right tools for the job. And I'm just going to get a little bit of solder on each of these terminals, being careful not to melt the back of the motor. Now, it really doesn't matter which is red and which is black. Because we've got the cog which is nearest the motor itself at the top there, we're actually going to want to go this way with the wires, because we're going to want to keep it as flat as possible. So I'll just get a little dab of solder on there. And I'm actually able to push the wire through the little hole on the motor, which is even better. You don't have to, though it can stick on the side, but you're going to get a better joint if it does go through the hole. And then I'm going to take one of these out, trying not to lose my little bearing. So remembering it's going this way round, so that's going to be like that. And because this has been printed with pt6b, sometimes you get a little bit of what they call stringing. These very fine sort of filaments of plastic, they usually just come off with your fingernail or a screwdriver. If you have a load of it in there, you actually want to get in there with a screwdriver or something sharp and just pick it out. It certainly doesn't do any harm at all. So I've got that lined up straight. This is my moment's truth. I haven't tried one of these with the motors yet. The wires are going straight down, so that's good. And it's quite a firm push, and the motor's sitting in there. I actually made a recess in the back of the 3D design, so the motor is designed to click in there and to stay in there. That's good. I don't think that's going to come out of its own accord. These wires are potentially a little bit vulnerable the way they come out of the back. So what I tend to do is put some tape on the back. Now this tape that I'm using here is just really some spare offcuts from the tape that I use on the 3D printer beds. Not the Prusa, but the Mini Delta. I think that any tape's going to be fine, but you do want to make sure that this isn't greasy. So again, I'm going to just isopropyl that. Then I'll stick a piece of tape over. They ought to protect the wires to some extent from being tugged. And then I'm going to put the motor back. For now, I'm just going to rest the wires in there like that, put it in place, and then I'm going to put them into the terminal block. I've got absolutely no idea which way around it needs to be, so I'm just going to put one wire in this side. There's a little tug, there's the other one. Just before I switch it all on, I just remembered that the speed controller needs actually to go into channel 2, so I'll just put it in number 2 as well. So turn the transmitter on, turn on the radio. Steering still seems to be fine. And the motors are going fine too. Now, the speed controllers do have a switch on them which allows you to have a brake when you try and go into reverse, and this hasn't been set in this case. If it was, the switch here would be in the up position, but it's actually in the down position, i.e. furthest away from the centre of the speed controller. That's the place that you want it. If you find when you're going to reverse that the thing stops and you have to go into reverse twice, you just change that, you turn the thing on or off, and then you'll be good. As it happens, we've got this going exactly the wrong way around. We could change the direction of the speed controller on the transmitter, but I'm not going to do that. I'm actually going to swap the leads around on the terminal block. So I'll just do that. Take my wooden block, move the flat around until it's at the top, pop a wheel on, and we have our first wheel done. You then go round doing each of the other 3 wheels in exactly the same fashion, testing to see which way it goes and moving the wires if necessary, and for the time being just leave all of the wires on the outside like this. I'll just go around and do those and then I'll be back. Maybe these aren't looking amazingly straight, but that's because we don't have the body on the top, but it's enough for testing it at this stage. Okay, so that's all 4 of them done. I'll just quickly show you. So I was actually going to go a little bit further in this video, show you how to tidy away these wires and how to put the mudguards on. I think that I'll save that for another day. I've probably had enough of filming for one day, and I think that this video, even once I've edited it right down, will probably be plenty long enough. So I think it's time that we all reward ourselves having got this far with a quick test run. Bruder test driver is ready, and honestly he's got no steering wheel, so I've just printed him a quick transmitter so that he can actually control it. And by the way, all of the prints which I'm using in my videos will be freely available on Thingiverse. I just need to get round to uploading them and categorising them, etc. So let's give it a quick test run. Well, I would hope you would agree that even though we haven't yet got the top on, which will actually hold these top pins in place properly, this is thoroughly satisfactory for this stage of the build. I hope that you've enjoyed following along with this video, and I hope even more that you're building your own telehandler. It is a very rewarding project, perhaps not one typically that people would do as the first model, but I think that step by step I don't see any reason why a person who hasn't done much modelling before couldn't achieve a perfectly satisfactory result. So in the next video, which, as I said, I think I'm going to make very short, we will just cover the tidying of the wires and the trimming of the mudguards so that they can fit on here. And in the more substantial video which comes after that, we're going to be sorting out the cutting of the components for the body shell, fitting the other speed controller, getting the electronics sorted out over here, and getting ourselves ready ahead of preparing to make the telescopic arm. As I think I've said lots of times, all of the parts for this build are included in the description, and I'm actually adding things to the description of all of the videos in this series as I make each of these videos and realise that there are more parts or particular tools that you might need. I hope that you've enjoyed this video. Feel free to post any comments or ask any questions in the comments section below, and until the next time, thank you very much for watching.